Welcome to the Deep Dive. We take interesting sources you send our way, and, well, we dive deep to pull out the key takeaways for you.
Helping you get up to speed fast.
Exactly. And today, we've got something that might sound a bit niche at first glance, the open sourcing of MS-DOS 4.0.
Yeah, a listener pointed us to Scott Hanselman's blog post on it, and it's actually surprisingly fascinating. It's not just about nostalgia.
Right. So, our mission, if you will, for this deep dive, figure out why looking at the source code for an OS that's what, nearly 45 years old, why that's interesting now.
And what it tells us about, how technology got to where it is today. Hanselman's post is our main source here.
Okay, so MS-DOS. I mean, it feels ancient tech-wise, but Hanselman mentions earlier versions, 1.25 and 2.0, were actually released years ago.
Yeah, about a decade ago as reference material. And the kicker, they were written entirely in 8086 assembly code.
Assembly. That's, wow. Building a whole OS like that, it's hard to picture.
Oh, it's a completely different world from today. Like, think about handcrafting every single piece of a machine versus, using modern power tools and pre-built parts.
So super low-level control.
Exactly. Precise control over the hardware. But incredibly labor-intensive. Every little thing needed lines and lines of detailed code. Power versus complexity. That was the trade-off.
Okay, now DOS 4.0. Hanselman calls its history complex and fascinating. So it wasn't just a simple update then.
Not at all. This is where Microsoft and IBM teamed up.
Ah, the big partnership. What made that whole situation so, well, complex?
Well, you had these two giants, right?
Yeah.
Microsoft and IBM trying to define the future of the PC. But they didn't always see eye to eye on how to do that.
Different goals.
Kind of. IBM was very focused on its hardware, its architecture, like the
Be the-
PS2 line. Microsoft was maybe thinking more broadly about software dominance across different machines.
So compromises were made in DOS 4.
Yeah, and those different strategies, well, they eventually led to them going separate ways, especially with IBM pushing OS2 later on.
And OS2 connects to this other thing mentioned, multitasking DOS, MT-DOS. That sounds intriguing.
It really is. MT-DOS was this branch that didn't really get a wide release. And this new source code release helps shed some light on that whole relationship.
So how did this old code even surface now?
Right, this is the really cool part. There's this researcher in England, Connor Hyde, who goes by Starfrost.
Starfrost, okay.
He got in touch with Ray Ozzie.
Ray Ozzie, former Microsoft CTO Ray Ozzie.
The very same. And get this, Ozzie had these old floppy disks stashed away from his time back at Lotus Development.
Floppy disks. Seriously. Containing what?
Unreleased beta versions of DOS 4.0.
Yeah.
Stuff nobody had seen before.
That's like finding a lost manuscript. What was Starfrost actually looking for with these?
His main aim, according to Hanselman, was to figure out the connection. How did DOS 4, this mysterious MT-DOS, and the later OS2 all fit together?
Ah, untangling the family tree.
Exactly. And these betas seem to be really early versions, potentially even containing the source for IBMBO.com, which is, super fundamental.
Wow. Okay, so it wasn't just Starfrost digging these up. Hanselman himself was involved.
Yeah, Hanselman and an internet archivist named Jeff Sponagel. They did the painstaking work of actually getting the data off those fragile disks.
The digital archaeology part?
Right. Imaging the disks, scanning the old documents. They called it the Ozzie drop.
Yeah.
It shows real dedication to preserving this history.
It really does. And it's great that Microsoft and IBM were on board.
Absolutely. They recognized the historical value and agreed to release the DOS 4.00 source code under the MIT license.
Which is a very permissive open source license, right? Lets people really dig in.
Exactly. Study it, tinker with it, learn from it. It's fantastic.
But wait, there's more to the story, something about Microsoft's archives.
Yes. So besides the Ozzie disks, Jeff Wilcox and the Microsoft Open Source Programs Office, the OSPO team, they actually searched Microsoft's own archives.
And they found.
The official MS-DOS 4.00 source code.
Amazing. So they got it from both ends, kind of. The betas from Ozzie and the official release code from the archives.
Pretty much. Although, it's important to note, the full source code for MT-DOS itself, that wasn't found. Still a bit of a mystery there.
Okay. So MT-DOS remains elusive, but what did get released is still substantial.
Oh, definitely. You get the MS-DOS 4.00 source, those extra beta binaries from the Ozzie drop, PDF scans of documentation, and the actual disk images. It's a really rich package.
Now let's talk tech details. Someone in the comments on Hanselman's blog noted it's all assembler, like 100%.
Basically, yeah. Even the simple line editor, Edlin, it's all assembly language.
That's just wild. Compared to Python or JavaScript today, it's almost unthinkable.
It really puts things in perspective. Think about drawing something on the screen. In assembly, you're talking directly to the hardware, manipulating memory locations.
Versus now, where you just call a library function.
Exactly. There's so much abstraction now, which makes development faster, sure, but you lose that direct connection, that deep understanding of the machine itself. Seeing DOS4 in assembly gives you huge respect for those early programmers.
The ingenuity required must have been immense.
Absolutely. And dealing with incredibly tight memory constraints, too.
Hanselman also mentioned the tools used to recover the data. Grease Weasel, FluxInGen.
Yeah, specialized hardware and software for reading old, potentially degraded floppy disks. You can't just stick a 40-year-old floppy in a USB drive.
Right. It needs careful handling.
These tools read the magnetic flux patterns directly, trying to reconstruct the data bit by bit. It's a whole field in itself, crucial for preserving this stuff.
And the coolest part, people have actually gotten this running again.
Yeah, on original hardware, like an actual IBM PC ST, which is amazing.
And XT, wow.
But also on newer Pentiums, and importantly, in emulators like PCM and 86box.
So if you're curious, you can actually boot it up yourself.
You absolutely can. Download the images, fire up an emulator, and experience 1988 computing firsthand. It's very accessible.
That hands-on aspect is key, I think.
Definitely. Reading about it is one thing, but actually interacting with it,
Yeah.
that gives you a different level of understanding. The limitations, the quirks, even the relative simplicity compared to today.
Looking at the reactions online, people seem genuinely thrilled about this release. Wonderful stuff, one commenter called it.
There's a real appetite for this kind of history. For some, it's nostalgia, sure, remembering their first computers.
I get that.
But for others, it's about understanding the foundations. How did we get from that to where we are now? It's a crucial piece of the puzzle.
Naturally, it leads to questions about, oh, what's next? People asking about DOS 5, DOS 6, source code.
Yep, saw those comments too.
Yes.
It's logical, right? If 4 is out, why not 5 and 6?
But it's probably more complicated. Someone mentioned drive space in DOS 6.
Exactly. As DOS evolved, it incorporated more third-party code, more complex features, maybe more tricky licensing situations. It likely gets harder to release the further you go.
There was also that comment about an earlier leak of DOS 6 code, though someone corrected it to being an incomplete 6.0 beta.
Right. The distinction between an official, sanctioned open-source release like this one and an unofficial leak is pretty important legally and ethically.
Makes sense. But it does show the underlying interest is huge.
Undeniably. Which leads to the bigger question someone posed. Why not just release all the MS-DOS source right up to Windows 9X?
Yeah, from a historical perspective, that would be incredible.
A goldmine for researchers.
Yeah.
But think about the sheer amount of code, the legal complexities, potential IP overlaps with other still active Microsoft products. It's likely a massive undertaking.
Probably not happening anytime soon then.
Probably not, but it's nice to dream.
One comment really struck me, the idea that modern developers might struggle to understand this code written by Gotti-like developers, as they put it.
Yeah, that's an interesting take. Maybe slightly hyperbolic, but there's a kernel of truth.
How so?
Well, programming and assembly back then required such an intimate knowledge of the hardware, such extreme optimization due to constraints. It's a different skill set than working with high-level languages and frameworks today.
So not necessarily better developers, just
Yeah,
different, focused on different problems.
exactly. They were solving problems at a fundamentally different layer of abstraction. It's fascinating to think about how programming itself has evolved.
And it's not just DOS fans who are excited. Someone from the OS2 community chimed in, hoping its source code might get released someday.
Yeah, highlighting the value of having an open-source hybrid kernel like OS2's available for study. It shows this desire for access to historical code is broader than just one OS.
The open source principle applies widely.
Right. Transparency, learning from the past, building on it. It resonates across different tech communities.
There was even some discussion about the nitty-gritty of the release itself, praising the archival effort, but also some critique about, like, timestamp preservation in the Git repository.
Which shows how seriously people take this stuff. Getting the preservation details right, including metadata like timestamps, is really important for historical accuracy.
Good point. But on a purely fun note, someone mentioned they're already running this DOS 4 release on their actual hardware.
That's awesome. Seeing people actually boot it up and use it, and that's the best outcome, really. Brings history to life.
Makes it tangible.
Totally.
Yeah.
And then there was the comment hoping for older Microsoft compilers, like C5.1, to be released too.
Right, to get the full development environment picture.
Well, interestingly, someone else pointed out that the release does include a tools folder.
Yeah.
And it seems to contain the actual installation files for Microsoft C5.1 and MASM 5.0.
Wait, really? So the compilers might actually be in there?
It looks like it. Perhaps an intentional inclusion to provide that context for how DOS 4 itself was built.
Okay, that's neat detail. So let's tie this all together for you listening. Why does this matter today in our world of AI and clouds and smartphones?
Well, it's like looking at the blueprints of a skyscraper. Even if you live in the penthouse,
Hmm.
understanding the foundation is crucial. This DOS 4 code shows you the fundamental building blocks.
Memory management, file systems.
Exactly. Concepts that are still relevant, just implemented differently now. Seeing how they solved problems with severe constraints, it can spark ideas. You learn about trade-offs in design.
And maybe appreciate the complexity we often take for granted now.
For sure. It's a direct look at how software was crafted in a different era. You might have some aha moments about why things work the way they do today. It's valuable insight, whatever your technical level.
Absolutely. So to sum up, we've seen historical weight of MS-DOS 4, this amazing rediscovery story thanks to Starfrost and Ozzy and Hanselman, and what exploring this code offers.
It's a shortcut, really, to understanding a key moment in computing history.
So here's a final thought to leave you with. What can studying the constraints and, frankly, the cleverness of these older systems teach us about building better, maybe even simpler software today?
Or maybe, how does seeing the bare metal simplicity of DOS change how you view the incredibly complex layers of software you use every single day? Something to chew on.
Definitely. We encourage you to check out the GitHub repo yourself. We'll link it in the show notes. Explore, tinker, and see what you discover.